Welcome to this presentation, Science Paper 1, 2024 GCE question, which came under electricity, and the question was brought on question B7. The question reads, figure B 7.1 shows resistors connected to a 4 volts power supply. The figure below, figure B 7.1, shows resistors connected to a 4 volts power supply. So here is our 4 volts power supply. And then we have been given 3 resistors. This is 6 ohm resistor, 12 and 3 there. The first question says what is the effective resistance of the circuit? So now when you look at the term effective resistance, we are basically talking about the total resistance. Effective resistance, we are simply talking about the total resistance. Now the question is, how do we get to find the total resistors? Bearing in mind that we have 3 resistors, the 6, 12 and the 3. So basically we need to understand how these resistors have been connected. When we look at the 6 and 12 ohm resistors, these two have been connected in what is known as the parallel. Okay, then these two in relation to these 3 would say that these are connected in series. So this and this one here, they are connected in series. Now how do we get to find the effective resistance for the series, for the resistors that have been connected in parallel and the series at the same time? Okay, so the first thing that we'll do is we are going to label this. We can label this as our resistor 1. Then probably we can label the 6 ohm to be our resistor 2, and the 12 ohm will be our resistor 3. Having done that, we now need to look at the formula. So for the parallel circuit, for the parallel resistors, the effective resistance, also known as the total resistance, is calculated by simply, number 1, multiplying the resistors. So in this case, we have the 6 and the 12 resistors having been connected in parallel. We are going to say R2 multiplied by R3. Then we divide by the sum of the same 2 resistors, that is R2 plus R3. Okay, so this formula here would give us the total resistance for the resistors that have been connected in parallel. Now bearing in mind that despite having these in parallel, we also have the other one there, the 3 ohm resistor, which is in series compared to this one. So now how do we get to find that? So for the series circuit or the series connection, the effective or the total resistance is given by simply adding the resistors that we have. So let's say we have maybe 3 resistors. We would simply say resistor 1 plus resistor 2 plus resistor 3, if at all the 3 resistors are connected in series. So for the series, would basically find the total resistance in that manner. Okay, now let us look at how our resistors are. Getting back to what we said these ones are in parallel, and then this and these, they are in series. So basically what we're going to do is we're going to combine the formula for the parallel and the series, and this is how we are going to calculate the effective resistance for this particular question. So we would say effective resistance, also known as the total resistance, will be given by, number 1, I'm going to have my R1. So meaning I'll have my R1, then plus, because we are saying this and these here, they are in series. Okay, they are in series. So we'll have R1 plus, according to the formula here, R1 plus, then the total for this. Well, how do we get to find the total for these ones which are in parallel? We are going to introduce our formula to say, we're going to say R2 multiplied by R3 divided by the sum of the same two resistors, R2 plus R3. Okay, so this will give us that our effective resistance will be equal to, this is 3, then plus, that is 6, and then by 12, this will be 6 plus 12. Okay, from this point we can basically say our total resistance will be equal to 3 plus, this is 72, 6 times 12, and then here we're going to have 18. Okay, so first to shift, going there, our total resistance is going to be given by 3 plus there we're going to get a 4. So the total resistance for this circuit, we're going to get 7 ohms, and this value here is what we are calling as our effective resistance. Okay, so that is basically how we find the effective resistance. Coming to the second question, question B, they're saying calculate the potential difference across the 3 ohm resistor. Where is our 3 ohm? Our 3 ohm resistor is right here. So for this question, we need to understand what the potential difference is. So the potential difference in a layman's language, we can simply say this one here is the voltage. Okay, the potential difference, we're basically referring to voltage. So what would be our potential difference there? So remember the formula for potential difference, we simply say the potential difference is equal to the current multiplied by the resistance. Okay, potential difference is equals to current multiplied by the resistance. Okay, and then do we have the current? We don't have the current, so we basically need to calculate the total current in the circuit. Why is it important to calculate the total current in the circuit? This is because if this and these are connected in series, therefore the current is always equal on each given resistor in series connection. The current is basically equal at each given point in series. So basically we are going to find the total current. Then once we have the total current, that will be the current that will be here, and that will be the current that will also be at this particular point. Okay, so what's the formula for current? So we are going to say current is going to be given by the total voltage in the circuit divided by the total resistance. Okay, and this formula is coming from the Ohm's law, which is resistance is equals to voltage divided by current. This is where we are getting our formula from. Okay, we've just made I the subject of the formula, or the current. So current is equals to our total voltage in the circuit. We have 4 volts there, that's 4 volts, then divided by what is our resistance. The resistance, the total resistance there, which is our effective resistance there, we've gotten 7, and this means that our current for the circuit above is 4 divided by 7. This is giving us 0.57 amps. Okay,